Good morning, students. So we'll move on to the very important topic of module number 3, that is Scada. Okay. The full form of Scada is Supervisory Control and Data Acquisition. Okay. So the name only indicates like supervisory control and data acquisition. Okay. So this technique we are using for what? For controlling and for monitoring the devices which we are deploying it for the IoT network exactly. And what we need to do, we need to collect the information. Okay, so according to the information, okay, like what variety of information you are going to get, okay, then what kind of information you are going to get. Based on that, we need to go for controlling the end devices or the smart objects which is deployed in the IoT network exactly. Okay, so this is working based on client and server or master and slave fashion. Okay, so the device which are all deployed in real-time environment, they will be working as a slave. Okay, and the applications server, okay, the Scada server what we are having, so that will be working as a master exactly. Okay, so between this we will be having the same type of like master and slave type of communication. Like if master is ready to establish a communication with slave, then it will send some signal to the slave, or else slave, if it want to establish a communication with the master, again it will send some communication message. Okay, if the connection logically get established, then we go for data transmission exactly. Okay, fine, we'll go through this data. Okay, so here we are splitting it as two separate part. Okay, so in this presentation we'll be going through like what exactly Scada was, okay, how it got evolved, okay, then what are the different problems we are facing, then what will be the solution for that. Okay, so one type of solution we are going to discuss in today's session. In next lecture we'll be discussing the rest of the technique exactly. Okay, so first we'll see what exactly Scada is, okay, for what purpose it was designed and all, we'll see that. Okay, designed decades ago, so this was designed decades ago, like previously we had. Scada is an automation control system that was initially implemented without IP over serial links before being adopted to Ethernet and IPv4. So by this point, okay, the basic scenario or basic characteristics of Scada is exposed over here. Okay, so one thing is the Scada is totally working over the serial fashion of data communication. Remember this. Okay, then later the Scada we already had. Okay, so later what we did, we deployed the Scada for the IP based network exactly, like IPv4 we are using over here. Okay, the latest version may be supportable with IPv6 also. Okay, but in our discussion we will be discussing regarding IPv4 exactly and Ethernet also. Okay, so this is some basic information regarding a Scada. At a high level, Scada system collect sensor data and telemetry from remote devices, okay, while also providing the ability to control them. Okay, so the sensor information, whatever we are going to receive by this Scada application server, okay, so this application server have a potential to control them. Okay, we'll have some discussion, right? Some examples are available. See, if any like if you are trying to control the room temperature, okay, particular room we have and it is enabled with AC, okay, air conditioning facility over there. Okay, your target is to maintain a 20-degree temperature over there. Okay, 20 if you want to maintain. Okay, then we will be having a temperature sensor obviously deployed in the that particular room. So whenever the room temperature drops below 19 or if it go above 20, okay, then automatically your AC should maintain the temperature of 20 exactly. Okay, for that we need to send some signal, okay, so that AC should be turned on or AC should be turned off. Okay, so such type. Okay, you may say like if we set the AC for 20, okay, then it will be constant, but the room occupation, okay, like how many members are occupied in that particular room, that also depend. If it is an empty room, then okay, it is very simple to maintain 20-degree over there. Okay, but if any occupant is available, then the room temperature will increase over there, right? Okay, for that, then Scada network can be found across various industries. Okay, but you find Scada mainly concentrated in the utilities and manufacturing industries verticals. Okay, so this Scada is used everywhere, but it is mainly concentrated over the manufacturing industries and the utilities. Okay, why we need to go for this? Because the manufacturing unit and utility will be spread over a huge area. Okay, so what we need to do, we need to monitor the whole system. Along with that, we need to get the information and we need to control the entire system over there. So there we can go for this technique called as Scada exactly. Okay, within these specific industries, Scada commonly uses certain protocols and communications between devices and applications. Okay, so fine, we'll see that what are the different devices we have to use and what are the different application or what are the different protocols we need to use. We'll see that. Okay, these protocols are serial based. Okay, so transporting them over current IoT and traditional network requires that certain changes to be made from both protocol and implementation perspective. Okay, so as I mentioned in the first part itself, like the Scada is working over a serial fashion, but rest of the IoT network, okay, total IoT network is working over a parallel fashion. Okay, per kind of communication it will be. Okay, so what we need to do, we need to go for some kind of adaptation over here, so that like in the perspective, like in the protocol perspective, what we need to do, we need to go for some certain changes over here, because of which we may end up with a proper communication over here. Okay, so what are those adaptation? Okay, or what are those adaptation? We'll see that. Okay, then adapting Scada for IP. Okay, so we'll see how we can go for deploying this Scada for IP based IoT network. Okay, the rapid adoption of Ethernet network in the industrial world, okay, draw the evolution of Scada application layer protocols. Okay, so we need to go for this application layer protocol for Scada. Okay, because obvious we will be using the Ethernet for the entire system. Okay, everywhere we are using the Ethernet. So if we are with outdated Scada system, then it will be of waste. So we need to go for some application layer protocols. Okay, we'll see that what it is. Then benefits of this move to Ethernet and IP includes the ability to control existing equipments and standards while integrating seamlessly the Scada subnetwork, okay, to the corporate WAN infrastructure. Then DNP3 protocol have adopted and evolved to utilize IP and TCP or UDP as both networking and transport mechanism. See this DNP3, the protocol what we are having. So this is totally working based on a Scada principle. Okay, it will be working in a parallel fashion itself, but okay, the income will be parallel. Okay, later it will be converted to serial. Okay, the internally DNP3 protocol for Scada will be working on a serial fashion itself, but when it will be transferred to the network, okay, when the Scada is trying to communicate with the slave or trying to monitor or try to command some devices, okay, which is exposed for the real-time environment over there. Okay, there it will be working on a parallel fashion exactly. Okay, fine, we will have a complete picture, okay, using which we can easily identify how it will be, how the DNP3 will be working on. Okay, like many of other Scada protocol, DNP3 is based on master slave, okay, control center or remote device relationship. So it is also working based on master and slave fashion. Okay, we'll see that how it will be and all. Okay, slave monitors and collects data from device that indicate their state. Okay, such as whether a circuit breaker is on or off, and take measurements including voltage, current, then temperature and so on. Okay, so the job of the slave is what, like it need to monitor everything, okay, so which is around this slave device. Okay, you can feel the slave as a sensor, some sensor, okay, which is deployed for measuring the real-time environment, okay, for any purpose it may be. So here we are having some like we're taking the measurement, okay, like a measurement regarding the voltage, current, then temperature and so on, many more. Okay, it is not possible like only one sensor can measure the voltage, current and the temperature all together. Okay, we need to go for different sensor for different purpose exactly. Okay, but the slave means what the sensors or the real-time object which is exposed for the real-time environment. Okay, so they will be sensing the information. So this data then transmitted to the master. Okay, when it is requested. Okay, when master requests, okay, a particular information from those sensors, so these kind of measured information will be sent back. Okay, master also issue control commands such as to start a motor or reset a circuit breaker, okay, and locks the incoming data. So the job of master is what? Okay, fine, they were received information whatever we are having, so that will be maintained, that will be logged. Okay, then later if you want to make some changes in the environment, or if you want to make some changes in the device end, then that is also possible by master exactly. Then connection management links, okay, the DNP3 layer with the IP layer in addition to the configuration parameters and methods necessary to or necessary for implementing the network connection. So here the DNP3, as I said, it is totally depends on the Scada principle, okay, and the IP layers, whatever we are having, who is working based on the internet protocol fashion. Okay, so they are at the one side. So intermediate, we need to go for some configuration or connection management links, okay, who is responsible for converting the data fashion of DNP3 to the IPv or IP version packets exactly. The master side initiates connections by performing a TCP active open. The outstation listen for a connection request by performing a TCP passive open. So here like the master, if it want to communicate with any device, then it will be communicating based on a TCP active open fashion. Means the master will send a request signal for the slave that I want to establish a communication. As a response to that, the device, the master, sorry, slave device, okay, whatever we are having, that will open, that will perform the TCP passive open exactly. Okay, we are calling it as like two-way shake hand principle exactly. Okay, both are, if both are ready for the communication, then communication will be established. Then master stations may pass multiple DNP3 data link layer frames from a single UDP datagram. Okay, while DNP3 data link layer frames cannot span multiple UDP datagram exactly. So this is what one of the drawback we are having. Okay, let it be. Then we'll go for the block diagram of protocol stack for transporting serial DNP3 SCADA over IP. Okay, so you can easily observe that there are total 7 different layers, both in the master end and in the outstation. Outstation stand for which is in the real-time environment exactly. Okay, you can observe there are 3 layers are available for DNP protocol. Okay, and we are having one IEEE standard like 1815, the intermediate one. Okay, then later we are having a IP layers. IP layers will be as usual your transport layer we are having. Okay, either it is TCP based or UDP based. Then later network layer we are having, which is working over a strictly IPv4 fashion. Okay, then later data link layer and physical layer we are having. Okay, so between these two we are having a IP network using which we can communicate exactly. Okay, but just observe, we are having a DNP3 protocol, is it right? Okay, here also we are having application layer, here also we have a transport function, which is nothing but a transport segment exactly. Okay, then link frames means the data link layers also we are having. Okay, but after this, the 7th layer, that is the intermediate one, which is the blue color we can find. Okay, so we are calling it as a connection management. Okay, who is responsible for transforming the information which is in a fashion of DNP3 to IP4 fashion exactly, and in reverse fashion also. Okay, like whatever the package we are sending it towards the master, sending it towards the application layer, so it should be converted to a DNP3 format exactly. For that we are using connection management. Okay, so we don't have a much in-depth discussion regarding that. Okay, so we'll go for tunneling legacy SCADA over IP network. Okay, so here if you are implementing the few layers, or if you are adopting few layers, okay, who can support for IPv4, okay, so you don't mean like complete the SCADA network whatever we are having can be processed as a IPv4 fashion. No, it is not possible. So what we need to do, we need to go for using some tunneling aspects. So first I would like to tell you what is this tunneling process exactly. Okay, see, this tunneling concept we studied between IPv4 and IPv6 exactly. See, previously we had IPv4 devices, is it right? The network was based on IPv4, but the number of devices we can accommodate was less in case of IPv4. Then we went for IPv6 exactly. Okay, so fine. The devices, the network devices, what all we are using to implement the concepts of IPv6, we cannot say like everybody will be IPv4 supported or IPv6 supported exactly. Few devices, few network devices are compatible with IPv4 exactly. So what we do, like we need to use IPv6 devices also, but in between sometime we need to go for IPv4 also. Okay, devices in case of devices. So what we do, feel that we are having a 3 devices. Device A, device B and device C. Device A and C are IPv6 fashion. Okay, device B is IPv4 fashion. So the packets, if you are transferring from A to B, so between that we are performing a process called as a tunneling. Okay, what is this tunneling? The packet format of IPv6 will be converted to a packet format of IPv4. Then it will be processed by IPv4 devices. Okay, then later it should be transferred for the further device, right? For the device is IPv6, the device name is C exactly. Then again we need to perform a tunneling process where we are converting a IPv4 fashion packet to IPv6 exactly. So this process we call it as a tunneling. It is just like a supplement. Okay, it is just like an intermediate broker we are using that process. Okay, we'll go through this. Then the transport of the original serial protocol IP can be achieved either by tunneling using raw sockets. So this is the first variety. In today's class we'll be discussing this regarding the raw socket over TCP or UDP. So this is the first idea, how we can perform a tunneling for legacy Scada over IP exactly. Okay, or by installing an intermediate device that perform protocol translation between the serial protocol version and its IP implementation. So 2 varieties we are having. First is what we can go for using a raw socket. We'll see that how it will be. Second is what we need to go for some extra third-party device who is responsible for converting this tunneling procedure exactly. Okay, fine. First, in today's session we'll be discussing regarding a raw socket. In next session we'll be discussing regarding the intermediate device exactly. Okay, a raw socket connection simply denotes that the serial data is being packaged directly into a TCP or UDP transport. A socket in this instance is a standard application program interface, okay, composed of an IP addresses and a TCP or UDP port that is used to access network devices over an IP network. Okay, figure 6.3 detail raw socket scenario for a legacy Scada server trying to communicate with remote serial devices. Okay, and RTU. Okay, so here we are using a like remote device called as a RTU. Is a multi-purpose device used to monitor and control various system applications and devices managing automatically. Okay, so if you want to manage these things automatically, then we need to go for a device called as a RTU. Okay, from the master and slave perspective, the RTU are the slave. So these RTU are the slave exactly. Okay, fine. So we'll go for the figure, okay, which is explaining the 3 different scenarios. In scenario A, you can observe a raw socket between router. Okay, raw socket between routers. In between the routers, we are using the raw sockets. Okay, no change on Scada server. There is no change in the Scada level. Okay, we don't have any problem. Okay, just observe this first scenario. We are having a RTU. I will go from left hand side. RTU we are having. Okay, so which is working over a serial interface exactly. You can observe there is a connection between RTU and the router in a serial fashion. Okay, router to router, you can observe over there. There are two routers which is communicating directly to the next router. Okay, so between that we can find the IP network. Clear? Between that we have IP network. So here we need to implement the concept of raw socket. Okay, you can observe raw socket master and client setup on routers exactly. So this raw socket will be managed in the router level exactly. Okay, then the last router, the third router what you are having, which is before the server, okay, Scada server. Okay, you can observe we are having a serial interface we are having, right? We are having serial interface exactly. Okay, say we are having these raw socket concepts will be implemented in router level exactly. Then scenario B, raw socket between router and Scada server. Okay, no Scada application change on server, but IP serial redirector software and Ethernet interface to be added. Okay, so here you can observe in scenario B, instead of serial interface between the router and the server, we are implementing the Ethernet exactly. We are implementing Ethernet exactly. So this is the difference we are having. Okay, so these are the different cases. Okay, it all depends like how you want to deploy the network. Then the third scenario, raw socket between router and Scada server. Okay, same, both are same. Okay, Scada application knows how to directly communicate it over a raw socket and Ethernet interface exactly. So these are the few adoption we can perform, okay, for implementing the concepts of tunneling procedure over here. Okay, so in next lecture we'll be discussing regarding the other adoption what we need to perform for implementing the concepts of tunneling. Okay, so till that, okay, go through this SCADA topic. Okay, the continued version will discuss in next session exactly. Okay, thank you students. So we'll meet with next session in next class.